Propped cantilevers. We will see one example. The fixed end moment for propped cantilevers, that's one end fixed and the other end simply supported, can be derived from the standard values given for the fixed beam and caster beams as follows. Consider the propped cantilevers on this below figure, which supports uniform distributed load as indicated, and this is the fixed end support, and this is the fixed end support, this is the roller support. Okay, this is uniformly loaded W kilonewton per meter. This is the span L. This is the VB reaction at B. VA is reaction at A. MA is reaction moment at A, because it's a fixed moment, fixed end. So there will be a moment it will be developing here. And the structure can be considered to be the superposition of in caster beam with addition of an equal and opposite moment to MB applied at B to ensure that final moment at the support is equal to 0. See here, this is the superposition of two beams, like here we have the fixed end moment. Considering this is a fixed beam, since here it's a roller support, there will be a 0 moment. So whatever the moment it's developing here, we need to put opposite moment, so that moment becomes 0. There will be a reaction, so there is no problem. So once we apply this kind of moment at here, there will be a carryover of 50% to this moment, like so minus MB we are applying, so it will develop minus MB by 2 at A. So at the final summation, if you see it, there will be a MA, that's MA minus 0.5 MB. Then at this point there will be a 0 moment here, and this will be W kilonewton per meter, that's a UDL. It will come 50% carryover will happen here, since this support is a roller support. We applied minus MB, then it will take 50% to this A. So already MA is here, so MA plus that minus MB 0.5 MB, that will come down. So let us see here. Let's see one example. Determine the support reactions, and bending over on diagram also we will draw for a propped cantilever, whatever it's shown here. This 10 kilonewton per meter is the load, 8 meters is the span. We will find out the bending moment and reactions as well. Fixed end moment. Fixed end moment for propped cantilever. Consider the beam fixed at both supports. So MA will be minus WL squared by 12, and MB is plus WL squared by 12. So W is 10, span is 8. So we will get minus 53.33 at MA and plus 53.33 at MB. So WL squared by 12 is the fixed bending moment. So this is the roller support. This is 10 is W, 8 is L. So moment MB must be cancelled out by applying an equal and opposite moment at B, which in turn produces a carryover moment of 0.5. That means 53.33 into 0.5 will become 26.67. So 53.33 plus 26.67 will become 80, and at this moment this 53 and minus 53, it will become 0. There will be a reaction here. So WL squared by 12, that's the 53 minus 53, and this WL squared by 12 is 53 fixed end moment, and after that we are applying equal and opposite moment to make a moment at B as 0. Because of that external moment, there will be carryover of 50% of that moment, so this will becomes in end 80 kilonewton per meter, and here 80 kilonewton meter moment, here 0 moment. So these are the fixed end moments, which M and MB. Carry over 50% is on here. So here we will see the fixed end moment, fixed end support. Consider the rotational equilibrium of the beam. We will consider MA moment at A equilibrium means like anywhere it should be 0, right? Moment at MA, considering MA is 0, summation at MA is 0. So this is minus 80 plus that VB, this is anti-clockwise moment, so VB also anti-clockwise moment, so minus 80 minus 8 is the distance, VB is the reaction force, 8 is the distance, so this should be 0. So from here we will consider VB equal to minus 10 kN, it will come. So once we know the VB as a minus 10 kN, vertical equilibrium if we apply, summation Fy equal to 0, so it will become VA plus VB equal 0, so VB is minus 10, so VA will become plus 10. Then next we need to see this as a simply supported case with external applied load. External applied load is 10 kN meter. So here it will become the moment MA about 0 if you consider 10 into 8 is the load acts at the 4 meter distance. So 10 8 into 4 minus this VB into 8 meter distance. So VB becomes positive 40. Then if you apply the summation about Fy equal 0, VA plus VB equal to then minus 10 into 8 equals 0, so VA we will get 40 kN, that is also upwards. So final reaction we can get it. So final reaction VA equal to VA fixed plus VA free, VB equal to VB fixed plus VB free, fixed and free and fixed and free. So this is VA is plus 10, this is plus 40, so 50, and VB fixed is minus 10, VB fixed free is plus 10, so plus that it will come. So considering the vertical equilibrium, total vertical force is 50 plus 30 equal to 80, that's matching. So fixed bending moment diagram is at this whole location 80 and this location 0, and free bending moment diagram is WL square by 8. So if we add these two, 80 at this point it will come, here it's a 0 only. In between the maximum is WL square by 8 is 80 kN meter here. Maximum bending moment will be, this is the WL square by 8, so the difference will be the maximum bending moment. And similarity we can see between the bending moment diagram and the final deflected shape. You see the tension at the top, and here is a tension at the bottom, and there will be a point of counterflexion. There will be a rotation curvature here like this, and here the curvature. So there is an inflection. Inflection means at this point there is no bending, right? Bending moment will be 0. So we can find the position of maximum bending moment by finding out the point of 0 shear force. So here reaction is 30 and the downward is 10 kN. So 30 minus 10 into x equals 0, if we see it, that x will become 3 meter. So we can see the maximum bending moment is 30 into 3, that's anti-clockwise, and clockwise is minus 10 into 3 is the load into 1.5, so 45 r. Area under this is half into this 30 into this 3, half into 30 into 3 is 45 kN. So let's create a new model, propped one. So we'll create it. We know that this is a 8 meter span and 10 kN, one end fixed, one end roller. So we'll create a grid. This is 8 meter span, so 2 nodes, 1 beam, and we'll go to the properties and create a section database. Apply the property for this single beam. We will consider W4 by 13. Then this we will assign to view. Its beam group is assigned. Let's go to the support. We'll create the fixed. Next one is roller support, that is fixed but release everything but except Y. So we will create that support. So we have created roller support here and pinned support here. So we have created the boundary condition. Now let's go to the loading. We will create a new load case. load case 1. Then we will add the load UDL of we will add the load for load case 1. That's member load in global y direction. That's minus 10 kilonewton meter, and d1 d2 it's throughout the length it's coming, so we will put d1 d3 and default value, add it. Now let's go to this load and we will assign this to beam. So now load is also assigned, boundary is also given. Now let's go to the analysis. We will add define comment and add this one, and now let's see, run the analysis. Once we are running the analysis, here 0 errors and warnings, go to the post processing. So now let's go to this view, go to the view and front view, you see it. So now this is the deflection pattern, we can see. Now we can see the deflection pattern. Here we see the deflection pattern, and here it is fixed. Here it is fixed, there is no slope, 0 slope it will come, and there will be a theta here, and the curvature is like this at this point, and this point's curvature is like this, and there is one point here. There will be a change in the curvature from here to like this. So this point is the point of contraflexure, that is a 0 moment. Okay, now let's see the bending diagram, beam results. This is the bending diagram. So here this is the point of contraflexure what we have seen, and this is the bending diagram. This we have seen from the analysis, it's 80, right? So here we will see the analysis 79.94. so from here, from this selection analysis, 79.94 it's coming, and here it's a 0, and this one value will be 49.3. The reactions also we have to see, right? Reactions here from analysis we have seen, here also, here we have seen 30, and here we have seen 50. So but in analysis in start pro it's going 49.993, and this is 30.08, so it's matching. So it is matching with these values. So deflection profile also it's given, and bending diagram also given. Let's see these reaction forces. Reactions we have seen 49.93 and 30.008. So that's the value here. So we have seen displacement, it's matching. The maximum displacement in y direction is how much? That is 8.817. That's almost 4 meter. Then we wanted to see the where this bending moment becomes 0, right? Here if you see we have seen like maximum bending moment occurs at where the shear is 0, that is at the 3 meter location. So here if you see it, that means 5 meters it should come, so 44.47 something is coming. That's the maximum bending moment on this beam. M is at 40.013 it's coming. So at 2 meter it becomes a 0 moment from here to here, 2 meter distance.